in the heart of the process of cement manufacturing.
The quarry. The story of cement manufacturing starts in the quarry. Raw materials, limestone and clay, are extracted from the quarry by blasting. Rocks extracted from the quarry are crushed into small pieces below 80 mm and routed to the nearby cement plant on a conveyor belt. Each quarry is subject to a rehabilitation plan adapted to its situation, including promotion of local biodiversity. Raw material pre-homogenization. Crushed raw material is then stockpiled in pre-blending beds in the pre-homogenization hall. The circular stockpiling is performed by a belt conveyor which continuously stacks circularly the material on the blending bed, and a scrapper that reclaims the stockpile transversely.
This method reduces substantially the chemical fluctuation of the raw material. Raw meal grinding. The pre-homogenized mix of raw material is then weighed, dried and ground in order to get a very fine powder with a maximum particle size of a few tens of microns. This step of the process is also the occasion to add some so-called alternative material that limits the use of virgin natural material. Those can be recycled or reused soil, sludge, sands or rocks from other industries, thereby reducing the global amount of waste. The fine powder thus obtained out of the raw meal is called the raw meal.
Raw meal homogenization. The raw meal is then transferred and thoroughly mixed in an homogenized silo in order to get a physical and chemical composition as consistent as possible.
The performance of the kiln and the quality of the resulting clinker depends on this operation. Preheater. The blended raw meal is then preheated up to 850 centigrades in the preheater tower using the exhaust heat of the kiln. The raw meal fed in at the top of the preheater tower passes by gravity through the series of cyclones in the tower. The hot gases from the kiln are blown against the flow through the cyclones, heating by heat transfer the raw meal. The efficiency of this process enables significant reduction of the CO2 footprint of the clinker. Burning. The meal, previously preheated at 850 centigrades, is then sintered at 1450 centigrades with a flame at 2000 centigrades in a rhetoric kiln insulated with refractory bricks that runs 24 hours a day and 7 days a week. The burning flame is produced by a high-technology burner nozzle in which fuels are injected. The fuels can be fossils like coal, but these are often replaced by alternative fuels such as biomass, recycled solid and liquid like used tires, animal meal, sewage sludge, olive stones. Successive chemical reactions take place in the sintering zone of the kiln that lead to the appropriate molecular combination to obtain the clinker. Cooler. The molten material is then quenched, meaning rapidly cooled, by an airstream in order to obtain the appropriate crystalline chemistry for the hydraulic properties of the clinker. Thus obtained, in the form of hard granules of a few centimeters, the clinker is then cooled down to approximately 100 centigrade and routed to the clinker storage hole. For the most efficient coolers, the exhaust heat is mainly recycled to the preheater, which reduces significantly the environmental footprint of the product. Clinker storage. The clinker cooled down to 100 centigrade is then transported and stored in a hole with a storage capacity of tens of thousands of tons. This allows the cement production to be kept going continuously, including during the kiln shutdown for annual maintenance, for instance. Cement grinding. The clinker is then ground with gypsum as a cement setting regulator and one or several other main additional constituents, natural, such as limestone and puzzolana, or recycled from industries such as slag and fly ash. Composition and other properties are specified in the European Standard of Common Cement EN 197-1. Other minor additional constituents may be added to the mix as well as grinding aids. At the outlet of the mill, the particles go through a separator in order to obtain a fine powder with a granular distribution targeted and consistent, called cement.
Cement storage. The cement is then stored in silos that contain thousands of tons of material. The silos may be internally divided.
Quality control. During the storage, the cement is sampled and chemical and physical analyses are performed as well as strength tests on mortars in order to certify its level of quality. Analyzers in cement plants laboratories reach a high level of technology like X-ray fluorescence and X-ray diffraction. New generation of samplers involve very high precision robots. The quality of a cement is recognized by the consistency of its composition and performances.
Bagging and shipping. In bulk, the cement is directly loaded into the bulk trucks underneath the silo.
In bags or big bags, the cement is first packed and then stored in a dry storage house before being loaded onto the deck of a shipping truck. For long distances, the shipping of cement can be done by rail, river, or sea.
The tour is now completed. We hope you have enjoyed the visit. Do not hesitate to discover, if not done yet, the jobs of the cement industry.